Hi everyone, I'm Farah from VoxMeta. Today we are doing a full unboxing of VoxMeta's flagship industrial 3D scanner, the H1 Pro. This is a comprehensive solution engineered specifically for high-precision metrology and challenging industrial environments. So I'm super excited to see the package content. So without further delay, let's do it. First of all, we have industrial carrying case here. Now scan the QR code so you can get the app link, all the information about the package content, and how to use the wired and wireless connection of H1 Pro right away. Let's open it and put it aside. And the first thing that meets us is a quick start guide. It's designed to help users complete device initialization in minutes and get straight to work. And quality certificate. First and foremost, let's have a look at our main hero, the H1 Pro 3D scanner. This is our core product, the H1 Pro industrial scanner. With a metrology grade accuracy of 0.050 millimeters, it is a powerful tool for the most demanding industrial tasks. Next one is power adapter. The power adapter delivers stable power to the scanner directly through the data cable. And also we have universal power adapter. These universal power adapters ensure our kit can seamlessly adapt to the power standards of different countries and regions worldwide. 1865 all lithium batteries, 4 packs. We have included 4 high-capacity 1865 all batteries. They support hot swapping, enabling 24/7 uninterrupted operation. And also lithium battery charger. The dedicated charger ensures you have a reliable power supply for long-duration field scanning assignments. The next component is our wrist strap phone holder. Paired with our mobile app, it turns your smartphone into a real-time preview screen, giving you total freedom from cable restrictions. USB-A to USB-C adapter. We also include a thoughtful USB-A to USB-C adapter, making the kit fully compatible with the late mainstream laptops on the market. Dedicated USB flash drive. Our dedicated USB drive comes preloaded with a software installation package and essential configuration files for both the H1 Pro and the calibration board. We have 3mm markers, 1000 pieces. 3mm markers are perfect for capturing fine, intricate details on complex workpiece surfaces. Also, we have 6mm markers. Specifically designed for large-scale industrial scanning, these 6mm markers provide exceptional tracking stability. Next one is USB-A to Ethernet cable. This USB-A to Ethernet cable ensures a high-speed, reliable wired connection between the scanner and various workstations. And also we have power cable. Next one is USB-A to USB-C cable. 5-meter aviation to RG45 cable. This 5-meter industrial-grade aviation cable ensures long-distance, high-stability data transmission, even in complex electromagnetic environments. Next is a core accessory, the high-precision calibration board. It's the cornerstone for maintaining the device's micron-level accuracy, ensuring every single measurement is precise and error-free. Finally, we have the manual turntable. When paired with a scanner, it allows for seamless 360-degree scanning of small to medium-sized workpieces, leaving no dead angles. And that concludes the full unboxing of the VoxMeta H1 Pro 3D scanner. Professional, powerful, and ready to go right out of the box. If you have any questions regarding the package content, please feel free to ask in the comment section below. See you in the next videos. Hello everyone. Thank you for joining us. I'm your host Farah from VoxMeta team, and you welcome us with another episode of live stream. Today we're going to be demonstrating the workflow with H1 Pro we have prepared some of the objects for you to show the performance of our new flagship industrial 3D scanner. So if you are new here we have our H1 Pro. This is a new product we have launched successfully on Kickstarter, so you can go ahead and see the specs and all the information that you need. Today we're going to be scanning this large-scale die-cast automotive component. We're going to be scanning the whole body using low resolution point spacing, and later we can use high resolution point spacing in order to scan these demanding areas with high details. So calibration board in order to stabilize the precision of our 3D scanner. Let me get the calibration board. Where's my calibration board? All right, we have calibration board here. Yep, this one is correct. Let's quickly conduct the calibration. First, we need to turn on our scanner. Let's use wireless mode as long as we can. I don't know how much battery we have inside because we used it last time and I didn't charge it. So it depends on our luck how much battery we have left on the tank. So we have two hot swappable batteries that you can charge using our charger, and even if you remove one battery, the H1 Pro still can run on the other one, so it provides non-stop 24/7 workflow. Let's go to the Wi-Fi settings of the PC and choose the correct one. 0031 is our SN, 4 last digits of SN number. So we choose this one and wait until the program identifies our 3D scanner. And then we can jump into calibration. Here we have it. Let's go calibrate it. The process is really simple and easy. You just need to follow the instructions and you're good to go. All right, this one from this side, and it is complete. Now let's go ahead and create new project. I can see that we have still 62% of battery from the last live stream session. We have left still this much, so we can work with it. Now let's go and switch to markers mode and scan the markers on the surface. So if you're new here, let me quickly introduce to you the H1 Pro. So we have, first of all, hardware. We have two industrial level cameras with minimized noise. Also, we have aviation connection to RG45 cable for stable power. We have Wi-Fi 6 and Bluetooth for gigabit wireless transmission. As you can see, in a wireless mode, we're still running without any lags, any delays. It is due to the fact that we have a Wi-Fi 6 connection, so the transmission is really stable and fast. Also, we run at 120 FPS frame rates and 4.4 million points per second capturing power. And now we completed we have completed scanning the markers. Now we can go to point cloud and set it up to the shutter to 0.5, the shutter to 0.5, and the point spacing to 0.80 to lower resolution, so we can quickly scan the all right. We're having a little problem here. This is because let's restart the program. Let's create new project and scan the markers quickly. Huh? Alright, we finished scanning the markers. Long press, double tap, and let's go scan it. As you can see, we're running on 120 FPS frame rate. Let's go to exposure to 1.5, and you can notice the scanning process is really smooth and fast. We can even reach this deep hole using the 34 crossline laser mode for fast and wide coverage scanning. This one is a huge and very complex object due to the difficult geometry on the surface. Nice and clean. Alright, we have also this part. While I'm scanning, you guys can say your country's name in the chat. We'd like to know the geography of our audience, so you can feel free to say your country's name in the comment section. And also, if you have any questions, you're welcome there. My colleagues will try to answer to your questions or any suggestions you have. So feel free to contact us. And again, I'm reminding you guys about the Kickstarter program. So if you wanna get this device, you can go ahead and place your order there. But this one is time consuming, but as you can see, I'm using the wireless mode, so the process is really easy and convenient. We're not tied to no PC or any other device. We have a total freedom of movement around the workspace. So this is extremely convenient and handy option. I believe we're almost there. You can see there's a lot of ribs and narrow slots. Also, it's got a lot of deep holes there if you wanna try to capture. But this is a very challenging object for any 3D scanner on the market. All right, almost there. So apart from 34 crossline lanes, we also have 17 parallel lines that we will try to demonstrate to you today. We have specialized objects that require 17 parallel laser modes for fine edges and surface texture. So later we will have to try and show you how does it operate. So stay tuned, and if you're not subscribed still, you can hit that subscribe button on our channel. You can also find us on the other platforms. You just need to search for VoxMeta, and also you can join our Facebook community. There we constantly updating new projects. So you don't want to miss out that. All right, now we finished scanning. Let me check it one more time. If we have this type of blind spots that we missed. So you can see here from this angle, I found out several spots that we missed during the first scanning. So let's go fix that problem. Nice. All right, from this side. Perfect. All right. we're done scanning, we long press on the play button and move on to processing it. We clean it up first, and later we can scan this area using high resolution point spacing, align them and stitch them together. Point spacing is quite rapid because we have built-in AI powerful chip that can manage to process such big, large-scale objects in a matter of seconds. Now, this one is quite big. It exceeds 2 meters long length, so you just need to wait a little bit until the program optimizes the point cloud. I can see that we reached 99%. That means we're almost on the finish line. Alright, and here you have it. You can see how deep we reached. Deep holes, deep pockets. Alright, now for this part, it's still not bad, but we're still gonna need to clean it up. Let's remove the plane first. Alright, perfect. Simply apply. We choose connected items so that we can clean it completely. Inverted choice, and we can delete these unnecessary parts. Alright, nice. And let's go create a new project and set the point spacing down to 25. The exposure to 0.5, and we can try to scan this part using high resolution point spacing. So you want to keep a distance between the object and the 3D scanner, otherwise you will have this pop-up screen that will tell you all right. This one is quite hard to reach due to the complex geometry you can see. But we can switch scanning modes. We have single laser mode for such occasions, for deep holes. All right. While using this mode, you want to make sure to move slowly because we have high concentrated power on the single laser. So all right, we almost captured everything on here. Let's go ahead and process it. All right, you can see it looks nice and clean. So we close this one. We come back here. All right, we just delete simply this part using lasso mode. and we go to stitching, auto stitching, and you can see the program automatically applied stitching. So now we have a complete model with high resolution details here. Let me show you the difference between low and high resolution scanning. As you can see, we have surface texture here that was successfully captured by our 3D scanner. Now we're doing stitching, and stitching is complete. As you can see, here is the difference between these two. This is lower resolution scanning, and this is the high resolution. As you can see, all the details are preserved, even the text on the here is visible, right? So this is large scale die-cast component for today. You guys can see how complete and nice it looks. All these ribs, all these blind spots, everything captured nicely and precise. Now let's go move on to another project, but before we have to move this object away so you can see everything clearly. I'll ask my colleagues to help me to move it. All right, thank you very much. Now we have to go back to our desk and scan the new projects. So today we have a small objects to scan. So for this we're gonna be using the turntable, manual turntable, and we have this object. You can see this one is a very small object with dense details on it. We will try to capture everything on it using our 3D scanner and using parallel lines. So let's go create new project. Let me apply some markers on the turntable so we have a stable tracking. I'll scan the markers first. Zoom out so we can see everything. All right, now we can move on to scanning. We'll set the point spacing to 0, this one to let's use parallel laser mode. Oh no, not the exposure. Let me zoom in. All right. While using parallel laser modes, you wanna move a little slower so that you capture everything. As you can see, this one is a quite small object. All right, now this part. Nice. And the last one is from this side. It has a lot of holes. And to make sure, let's use single laser mode also, so that we can capture everything on here. All right, perfect. Now we can stop scanning and let's go check out the results, how accurate the details are with this small object. So our 3D scanner can scan from 5 millimeters up to 5 meters. So starting from this small, even smaller objects up to a whole car frame. All right, we're finished. Now just check out the results. They look very nice. Let's remove the plane first. All right, now let's go clean it up. Apply, choose associated point spacing, inverted choice. Now check it out. Check out how nice the details are. They're minute, they're really small, but our 3D scanner was able to capture them. So check it out. You can see we have holes. Let's check out from behind. You can see that we have a lot of holes here, and they all were captured very accurately and precise. So yeah, this was it. Let's mesh it up and see. Let's choose closer to reality and apply. While we're doing this, I noticed that we have run out of batteries, so let's, for the rest of the live stream, use the wired mode. We forgot to charge the batteries. So we have aviation connector to RG45 cable. It's quite powerful and it's very durable and vibration resistible, so it's not easy to drag it out. And now you can check out the meshed model that you can export into STL and import into a CAD modeling programs for further processing, right? You can see how clean it looks. Let me save this project so we can upload it to our Facebook group where you can download it and check it for yourself. Now let's go create a new project and scan the new object. We have this one here. This one is quite small also, but it has some interesting geometry on it, steep holes. We'll try to capture it and see how it looks like. Traditionally, we scan the markers on it first. All right. Now let's go ahead and scan the object itself. We wanna use cross line for now. This one is a quite small object, so it demands some time. Let's use parallel lines, check it. Nice, let's use the single laser mode. All right, on this side, so we can rotate it this way and capture from different angle. Nice and clean. Also this one, perfect. All right, nice. Let's switch to cross lines. Scan this part. All right. Let's finish it. Now, I hope I captured everything. It looks like I did, but still we need to make sure everything is intact. All right, now you can see how clean it looks. All right, let's apply and see the results. You can see these deep holes, how accurate they were captured. Let's choose closer to reality and see the final mesh model. And here you have it. You can see that even the text on the surface was captured accurately, the deep holes. There you have it, this part. A very solid scan. Details were preserved very well. So this is it. Let's save this one also and move on to the third object. This one is also quite small. You can see it has a lot of interesting geometry, deep holes. We'll try to scan it from two different sides and align them, stitch them together later. Let's do it. Now I want to apply some markers around it. so we have a stable tracking, right? All right, nice. Let's create new project. Let's put it to 0.25, 1. Okay, scan the markers first. Nice. Start scanning. We're up to a very good start. You can notice the speed, 120 FPS and 4.4 million points per second. Here in action. For alignment, you want to make sure to have at least 3 common markers so that program can successfully identify the position of the object and align them successfully. Alright, so this was due to the fact that I moved the turntable too fast, so we're gonna have to cancel this one. Alright, we create a new project. We scan it one more time because I moved it too fast, so the scan was not successful. You want to make sure to move little slowly the turntable. The rapid movement can abrupt your successful scanning process, so you want to make sure to move it a little slower. All right, this part. Nice. And now for this part, let me use single laser mode to capture these deep holes. All right. Nice, and we can stop scanning and clean it up. Here you have it. Let's go delete the surface. Nice. Applying. Now we have clean mesh. This one we can delete. Okay, let's create a new project and scan it from the other side. Scan the markers first. Alright, we're finished. Let's go ahead and clean it up. Nice. And this one, worth the choice. Okay, now we can try to automatically stitch it. And you can see that stitching is successful. The program identified the object, and let's go apply it and see it. And here you have the final result. You can see we captured these deep holes and aligned them, stitch them together. Let's go mesh it up, go higher quality, and check the meshed file. And here you have it. Had this texture. It's from backside. You can see how solid and complete it looks. I'm very satisfied with the results. Let's go back to a main page and create new project and scan the remaining objects for yourself. Alright, new project. Point spacing up to 50 markers. Double tap on an M button. Let's go. All right, almost there. Nice. And let's check the results, right? All right. Right, nice. And let's go down a little bit. Nice, apply. Inverted choice, clean it up, and mesh it. And here we have the final result. You can check it, how clean it looks. Very solid scanning. Let's switch to solid plus wireframe and see the results one more time. Here you have it. Now we can go back. So this was this object. We can go back to the main page and create new project for the last object we have here. This one. This one. We're scanning markers first, per usual, and then move on to scanning the object itself. Once again, I'm reminding you guys about our Kickstarter program that we have launched already, so you can go ahead to our page on Kickstarter and place your order with best price option available currently. All right, let's make sure we captured everything. So we'll run it one more time. Perfect. Now we can finish it. Long press on a play button so you can finish the scanning. And now let's go process it. I can already see that our scan looks very solid. All right. Let's apply. I can already see how clean it looks. You can see that we have captured all the geometry on the surface, all the curves, bends, and the rest of the details, how nicely they were captured and preserved. Just look at this. Let's check it from this angle, from here. Also like this. I'm super satisfied with the results. Let me save this file and then we can wrap it up for today. Thank you guys for joining us. So today we've shown you how we scan the large scale objects, how we scan it with higher and lower resolution, and how can we stitch them into one complete mesh model. Also, we demonstrated how accurate the H1 Pro can capture these small sized objects with a lot of complex geometry on it. So this is not a challenge for our 3D scanner, the H1 Pro industrial grade 3D scanner. So you can head out to our webpage voxmeta.com to place your order right now. And if you're not subscribed, please hit that subscribe button and like button and leave your opinion, your suggestions or remarks on the comment section. The feedback is very important for us. And see you in the next upcoming live sessions. See you guys. Guys, today we're visiting our quality inspection lab to demonstrate the measurement of a ball gauge. To ensure absolute precision, this facility is climate controlled, maintaining a constant temperature of approximately 20 degrees Celsius and stable humidity. So let's go check it out. Every ball gauge has its own precision information. In order to get the report, you just need to scan the QR code on the ball gauge, and it will redirect you to the website where you can check the information. And now we can start scanning the ball gauge itself. Alright, we finished scanning. Now let's go to the measure and check out the results. First, we're gonna measure the scan number 3. Alright, create feature. Okay, now number 2. So far the results are pretty nice. Precision is really high, and let's go check the number 1. Yeah, precision is very accurate and stable. Hey guys, today we're visiting our quality inspection lab to demonstrate the measurement of a ball gauge. To ensure absolute precision, this facility is climate controlled, maintaining a constant temperature of approximately 20 degrees Celsius and stable humidity. So let's go check it out. Every ball gauge has its own precision information. In order to get the report, you just need to scan the QR code on the ball gauge, and it will redirect you to the website where you can check the information. And now we can start scanning the ball gauge itself.